we're still dealing with lines here, 1.3. Like I said, you're getting the same thing that you've seen before. There shouldn't be anything on here that bothers you. Now again, if you forget how to deal with slope, it's y2 minus y1 over x2 minus x1. Always understand it's going to be the change in up and down over the change in horizontal. Now you might have seen this in physics as delta y over delta x. Delta is just basically change in y over the change in x. So it's nothing spectacular, nothing you haven't seen before. Rise over run is always a good way of dealing with that. Okay. Now you'll, like I said, delta y over delta x, that's average rate of change, which is still the slope. It doesn't matter where you go on here, it's always going to be the same. Now, the thing is, we'll also be talking about delta y over delta x when we start talking about curves. Okay? And that's actually comes to the concept of acceleration. But you guys should be able to deal with that without too much of a trouble, without that too much of a trouble. Yes? Right? Sure. I mean, you've only been doing this for how long? A few years. Okay. Slope of a line, positive, upward, left to right. Always evaluate any graph moving from the left to the right. Because if you think about it, if it's a function, we're usually putting in values starting at the lowest most point, going up to the highest most point in our domains. So that's why I always look at it from left to right. Slope of the line is negative, goes downhill. Slope is 0 when it's a horizontal, and slope is undefined or no slope. You'll also see it identified as that when you've got a vertical line. So, let's see. Graphing a line at a point on a slope. This is nothing new to you. Graphing a line. Equation of a vertical line. Anytime that you've got x equal to a value, you've got a vertical line. Find it on the intercept, go straight up and down. Big deal. Point slope form. Now, we've got slope intercept form, y is equal to mx plus b. More often than not, you're going to be given a point and a slope. Or if you're given 2 points, you can go through and find it. So this is something that you've done in the past, so it really shouldn't be too much of a mystery to you. Just remember that your point x1 and y1, where they go. Distributed property, move y1 over and away you go. Horizontal line. If you're given a point, you need a horizontal line. Well, horizontal is measuring on which axes? X or y. Y. Parallel to the x, going on the y. Find the y coordinate. Equation of a horizontal line, y is equal to b. So if you get it in slope-intercept form, whatever your intercept is, that's horizontal line. No big deal. Okay. Slope-intercept form, like I said, this is nothing new. Slope and y-intercept, that's it, nothing new. Okay. General form. Now, I know we talked about this a little bit last year. General form is always ax plus by is equal to c. There are some things that are kind of handy for this. Okay? Now it says that x is always going to be equal to c over a when it's a vertical line. One of the things that I want you to add into this thing is if you see it in general form, what is its slope going to be? Well, if you were to go through and solve this for y, okay, you'd move the x over, correct? So that would make it negative. Then you divide by b. So the slope on a general form of the equation is always going to be negative a over no. Over B. So in your notes, that might be something helpful for you to have. That way you don't have to sit there and try and redo it. You just pick out A and B, and it's negative A over B, and you've got your slope right away to go with. Okay. It's a handy thing to have. Okay. So, what else we got here? I don't think. I don't think. Okay. You guys know about parallel lines, right? Kind of like the train tracks. You don't want it. They got to stay the same distance apart, relatively. So they're parallel relative to each other, right? Gotcha. So, rise and run, they'll always have the same slope. They will have different y-intercepts. That's just the way it's got to be. So, if you want to show that two lines are parallel, all you have to do is identify that the slopes are the same. Same slope, parallel lines. So, parallel, if you want to find a slope, again, you're going to give it a point and a slope. So if I want to find a parallel line for this that goes through 2, -3, well, what's the slope of this one? -2. Yeah, because it's A over B, negative A over B, so it's -2. So you know that it's going to have a slope go through that point. You use point slope. Nothing different about that. Perpendicular lines. Opposite reciprocal is exactly correct. So as long as you can remember that, you don't have a problem with that. Like I said, this is mostly review because you guys have had this beaten to death over the years. So that would be it. If you got questions, make sure that you take the time to ask.